All right, you can go get started. So I'd like to introduce Grace Mcculloch from the University of New Hampshire at Great Bay National Estuarine Research Reserve.
Thank you. I'm really excited to be here today. I think Kelly and I were just saying how great it is to have so many people in one room that already knows so much about so much growth. That's like something that never happens in our area of research. So I'm really excited about that. As Tracy mentioned, I'm from the University of New Hampshire. I'm also a graduate research fellow at Great Bay National Estuarine Research Reserve. And my master's work is titled Assessing the Ability of Salt Marsh Prioritization Tools to Predict Critical Habitats for Tidal Marsh Birds. I have a lot of different pieces in my master's research, and I'll be highlighting a few of those today. But know that there's more, and I'd love to talk more about other things too. I'm fortunate enough to work with Rachel Stevens from Great Bay National Estuarine Research Reserve, and also my faculty advisor, Adrian Kovach from the University of New Hampshire. You've probably heard a little bit about SHARP already today, the Salt Marsh Habitat and Avian Research Program. But the thing that I love to really highlight about them is that there are so many different partners that are working in the Salt Marsh Habitat and Avian Research Program. And I'm just one of the grad students that is a part of that effort. And so all of these different partner groups are working really to understand the science behind tidal marsh bird conservation. And I just love that there's such a wealth of knowledge, people just like yourselves looking into salt marsh fire research. Like many of you, I work in salt marshes. It's exciting to be here with birders who see salt marshes as this great opportunity for birding. That's rare with a lot of the people I speak to. But I also like to remind people how important our salt marshes are for our communities. Salt marshes protect our shorelines from erosion, they reduce coastal flooding, they enhance water quality, they promote carbon storage, they store more carbon per acre than an acre of forest, and they're promoting healthy fisheries. So along with essential wildlife habitat. So wildlife is really just one part of that puzzle of the many ecosystem services that our salt marshes are providing. The other side of the story with our salt marshes is accelerated rates of sea level rise. We've had past marsh modifications that have changed our marshes, including ditching for mosquito control and agricultural practices. But accelerated rates of sea level rise is a new threat and really on an unprecedented scale. This is a photograph of Hampton Marsh in New Hampshire in 2021 at a king tide. And you say, where is the marsh? Basically, everything that is water is marsh. And these kind of events are expected to increase in frequency and intensity, but we're also just going to see increases in sea level rise on a new scale, which maybe isn't as dramatic as this picture, but will still have a big impact on this important ecosystem. And we are seeing the marsh fail to keep pace with sea level rise already in Great Bay, New Hampshire, where the rates of sediment accretion are not keeping pace with the increase in sea level rise. So this is something that's happening now, but as we know, kind of a bleak picture for the future as well. The good news is that many managers are looking at ways to restore this ecosystem in the face of accelerated sea level rise. And some of those techniques include things like thin layer sediment placement, ditch remediation, so healing over some of those old mosquito ditches or agricultural ditches, runneling to restore single channel hydrology, and then microtopography. And all of those techniques are really designed to build elevation for that resiliency of sea level rise. The question is, as we work to maintain the critical ecosystem services that our marshes provide, how will that impact and how can managers look to prioritize critical wildlife habitat in those plans? And one of those species that many of you are familiar with is salt marsh sparrows. They're a flagship species at the moment for restoration. Everyone is talking about them and their conservation priority throughout their range. You've seen this map already today. They breed from Maine to Virginia. And as their name suggests, they live exclusively and nest exclusively in salt marshes. And you've also seen this figure, this really steep decline, 9% annual population decline throughout their range. And in New England, we're dealing with 12.2% decline. And there's risk of extinction between 2035 and 2060. So managers are looking at ways to prioritize habitat for this bird. This is just a visual to show you kind of what it's like being a saltmarsh sparrow. The marsh is ever changing, and you can go from your habitat looking like this and rear low tide to 6 hours later looking more like this. And as we learned a little bit earlier today, flooding is the primary cause of nest failure for the species. And this picture is a common sight on marshes across the nation. They need about 23 to 26 flood-free days to successfully nest. And while they are living in this challenging environment, they did evolve a unique adaptation to deal with the frequent tidal flooding. They can rapidly re-nest after their nest fails. And so they need 23 to 26 flood-free days that can fit just within the 28-day tidal cycle between the peak high tides around the full moon. In New Hampshire, we currently have 2 salt marsh prioritization tools, and these are used by managers to identify priority areas for restoration in the state. One of those is from the Atlantic Coast Joint Venture, and that identifies salt marsh restoration priority marshes with patches. And then the second is from Great Bay National Estuarine Research Reserve, which identifies priority habitat within the state of New Hampshire. And so both of these models were developed that are thought to support salt marsh sparrow habitat, but they didn't explicitly consider tidal marsh occupancy or abundance in their modeling. And I'll get to how I'm planning to address that in the future. But the other thing I'd point out is that the polygons are pretty large. They're not really telling you where salt marsh sparrows are actually going to nest within those polygons. And we know that salt marsh sparrows can be quite picky in where they're choosing to nest. So the overarching research question of my project is how well do tools which rank marshes based on habitat availability and sea level rise resiliency, along with other habitat factors that weren't included in those tools, predict salt marsh sparrow occupancy, relative abundance, and then productivity in New Hampshire. And my project has 3 questions. For this talk, I'm going to focus on the third one, but I'm also looking at what features best predict salt marsh sparrow occupancy and relative abundance in the state. Those are things like vegetation layers that are publicly available, field-based surveys, tidal range, those kind of things. And then I'm comparing those features to the ones that are actually used in the current maps to see if there's a disconnect between the features that I find to be most important when we're making up those decisions. And we suspect that there is, because we know that areas where we see a lot of salt marsh sparrows, some of those are being left out in the mapping tools. And so we want to make sure that those are included in those tools. The third piece is going from a landscape scale, looking more at within an occupied marsh, where are the salt marsh sparrows nesting? So within a salt marsh sparrow occupied marsh, what features predict where nesting is likely to occur? And can we use surface elevation, tidal range, and remotely sensed vegetation to predict this? So to collect, first of all, the nesting data, in 2023, I did an intensive nest searching effort at 4 different sites in New Hampshire. 2 of those are on Great Bay, and then 2 of those are along the coastline of New Hampshire. And following salt marsh habitat and UV research program protocols, I did intensive nest searching at each of those sites, going to that site every 3 days, looking for nests, and then once a nest is found, tracking its fate over the course of the breeding season until it either fails or fledges. And so I surveyed a total of 51 nests. And for every nest that I surveyed, I also surveyed a random point. So an area where there was not a salt marsh sparrow nest that is, and the random points were previously generated. So there's no bias in where you're choosing to put your random points. At each of those nests, I collected the data like field-based vegetation. So that's a 1 meter quadrat around the nest or the paired random point. What is the community cover in that quadrat? What does the vegetation community look like? And then I also assessed the elevation of the marsh surface at each of those points. So looking at the elevation of where the nest is located, but also the paired random point. And then I also calculated the site-specific water levels. And in order to do that, I installed water level loggers at each site to track site-specific water, because we know that at different sites, the hydrology can vary greatly. And I'll talk a little bit more about that later. I am also currently working with a high-resolution tidal wetlands cover layer, seeing if we can predict where salt marsh sparrows are likely to nest using remotely sensed data. And that's something that I'll be working on in the coming months. So just a little bit of some vegetation results. As expected, there was about a 10% difference in Spartina patens cover between nests and playground points. So nests had more Spartina patens cover on average. And Spartina patens tends to be that higher marsh vegetation grass. And then there was no difference between nests and ground points with regards to Spartina ultiflora cover, which tends to be that vegetation that's growing in more of the transitional marsh or the low marsh areas. And as far as elevation of the marsh surface where nests or random points were located, there was a significant difference in elevation, with nests being at a higher elevation placed within the high marsh platform. So salt marsh sparrows were choosing nesting locations that were at a higher elevation. But elevation doesn't really tell you the whole story, because the same elevation value at one marsh could look very different at another marsh with regards to what's happening with the water on the marsh. If a marsh is impounded, the elevation at, say, one value could be completely fine and the nest would never get flooded. But at that same value at a different marsh, that's open to tidal inflow, that value could be underwater for most of the time. So looking at the site-specific water levels is where I'm headed. Using our water level loggers, we collected 15-minute time series data for the whole breeding season of salt marsh sparrows at each of our sites. And so this is an example of that data at Lumberland, one of my sites. And you can see the peaks in the lunar cycle at the highest peak tide, kind of corresponding with the full moons. And you can see there are 4 peaks. And so I took the average peak highest high tide value, so that peak lunar cycle value on average for each site. And I also took the average daily high tide value. So we're getting a sense of what's happening with the monthly highest high tides at a site and what's happening daily with the high tides. And then I was then able to calculate, well, what does that water mean for a salt marsh sparrow nest on the surface of the marsh? How much water on average is at that nest marsh surface, so the surface where the nest is built up in the grasses right there? How much water is there on average during the day at the highest tide, and then at the monthly peak tides? And I'd be happy to talk more about that at the end. But basically, I found that there is a significant difference in where sparrows are nesting and where sparrows are choosing not to nest in the high marsh platform between the daily high tides. So they're nesting on average in areas of the marsh surface where the water is well below the marsh surface. And then here they're nesting, the water is still below the marsh surface, but it's a little bit higher. So they're choosing to nest in areas where the water is lower at the daily high tide. And then they're also nesting in areas where the water is lower at the monthly peak tides. And so you see here, there's about a 4 centimeter difference in the water height at the marsh surface where they're nesting versus where they're not nesting. And 4 centimeters doesn't sound like a lot to many people. For some reason, what is that? But for a salt marsh sparrow, where you're nesting in the marsh grasses, you know, a couple centimeters, 3 centimeters can be the difference between success and failure. And it was the difference between success and failure in Rhode community study in Maine. A few thoughts, I mentioned that, the importance of a few centimeters in elevation. And I really want to underscore the importance of understanding what's happening on the ground at a specific site, what's happening with the water level, because elevation is really a proxy for what's happening with the water. the water is what's going to flood a salt marsh barrow nest. And this really underscores the importance of projects that increase elevation and or reduce water height, even by a few centimeters. And those can play an important role in salt marsh barrow conservation. As was mentioned in a few of the other talks earlier, we don't yet know what the best technique is for restoring a salt marsh barrow marsh, but we do know that restoration is happening. And so pre and post monitoring will be key as we look forward to the future and identifying what techniques are best for salt marsh barrows. And we know that elevation and water play an important role in predicting where they're going to nest and their success. So anything that builds elevation could have potential to help restore a marsh for salt marsh barrows. I'm fortunate enough to work with a lot of lovely people, including many great salt marsh barrows, and many different partner organizations. And I guess I just say I'm really thankful for the work that we get to do and to learn from you guys as well. So thanks, and let me know if you have any questions.